I'm going to be doing video number 11a. A cylindrical hoop of mass equals 3 kilograms, radius equals 0.2 meters, has a rope wound around it with one end tied to the ceiling, as in the figure above. The hoop is dropped and falls while the rope unwinds and spins the hoop. After the hoop drops 2 meters, what is the downward velocity of the center of mass? Show all your calculations. Okay, so this is the diagram. Both of these are the same. This is the before and this is the after. So before, there's this hoop that is tied to the ceiling with a rope. It has a radius of 0.2 meters and its mass is 3 kilograms. And so it unwinds, it unwinds down and falls downward 2 meters. And so this is after it falls downward 2 meters. And so what we need to do is we need to find this velocity, the velocity of the center of the mass of the hoop falling downward after it goes down 2 meters. Okay, so what do we know? We know that there is rotational kinetic energy. And so rotational kinetic energy is equivalent to 1/2 mass times velocity squared, which is normal kinetic energy in the linear direction, plus 1/2 I inertia times angular velocity squared. And that is the kinetic rotational energy. And we also know that there is potential energy. Since this hoop is falling downward, it has a height of 2 meters, so that means there's potential energy. Okay, and we know the inertia of the hoop is mr squared, and we know that velocity is equal to angular velocity times radius. So we can plug those two into our rotational kinetic energy equation. So we make that equal to potential energy because it's originally just potential energy that's equivalent to rotational kinetic energy. So you do mgh is equal to 1/2 mv squared plus 1/2 iw squared. And we know that I, which is inertia is mr squared because the inertia of a hoop is mr squared. And we know that angular velocity squared is just velocity squared over r squared, or v over r squared. And so you plug that in, and so your radius cancels out, so mr squared. See, if you square this, that will be velocity squared over r squared, so radius cancels out, and you're left with mgh is equal to 1/2 mv squared plus 1/2 velocity squared. And then you cancel out mass, because mass is in every equation, and you can cancel out mass, and you're left with gravity times height is equal to 1/2 v squared plus 1/2 v squared. And so that's just equivalent to v squared equals gravity times height. Then you just plug in gravity, which is 9.81 meters per second squared, times the height, which we know is 2 meters, and you square root that, you solve for v, and you get 4.43 meters per second. And so this relates to what we've been learning in class, because we've been talking about rotational kinetic energy and inertia and motion, and that's how this relates to class. Thank you.